I am Elif Deniz Karabaş. I'm a freshman at Bilkent University. My department is Electrical and Electronical Engineering. My project aims to calculate the G constant by the range of the projectile motion. The equipments that I will be using are a spring to manage the angle of the projectile and to give initial velocity, one puck, carbon and regular paper to collect data, and two pedals to activate the system, and a ruler to measure the initial velocity and the range. I also used a spark timer to collect the data to arrange the frequency of my shots, and a wooden block that has a arranged sinus degree on it. For the sakeness of easiness of calculations, I arranged the angle of the table as 0.16 degrees. After taking the second derivative of the position function with respect to time, we can reach that there is acceleration only in the vertical direction, which can be said as there is only change in the velocity in vertical direction, and the horizontal velocity is remained constant. After kinematic formula is applied to both x and y components, which are horizontal and vertical dimensions, we can reach that when the parameter t is eliminated, these equations satisfy a parabola. To find the maximum value for the range, we reach to this formula. I did the calculations by determining an origin from the shooting angles. I measured an initial the speed with the distances of the initial dots, and I measured the range with the ruler. But with some projectiles that didn't do a complete projectile motion like this one, as you can see, it's not like this one. It's not complete. I found the maximum height and then calculated the range by multiplying this distance by 2. The first table I obtained is when I did the calculations during the performing of the project. And the second table I obtained is the table that I created for the easiness of creating the graph. I plotted the graph by using a code in Python, and I found the slope of the graph, which gives me the G constant that I calculated as 6.86 meters per second square. I obtained a 42% error. The reasons for this might be because that the area of the Airtable was not large enough for me to observe enough times of complete projectile motion. As you can see from the previous video, some projectile motions that I obtained were complete, but some weren't. That is because of the area issue on the Airtable. And also there might have been some damages occurred on the regular and the camber papers. If these issues are completed, then the rate of the error might decrease.